Welcome to the DIY Honda Garage channel. The Diagnostic Trouble Code, DTC C1244-1C, indicates an issue with the brake pressure sensor 1's supply voltage in the Honda Civic model year 2022 and newer. This error arises when the electric vacuum pump control unit detects an abnormality in the voltage supplied to the brake booster pressure sensor. This sensor plays a crucial role as it aids in monitoring the brake fluid pressure and ensuring optimal braking performance. The sensor is typically located near the brake booster, providing real-time data to the control unit. Inadequate or excessive voltage supply can lead to system failures, putting both driver and vehicle safety at risk. The diagnostic process begins with understanding the components involved and their specific functions within the braking system. The DTC C1244-1C primarily affects the brake booster pressure sensor 1, which is vital for monitoring the pressure of the brake system in the Honda Civic. This sensor, located adjacent to the brake booster, plays a key role in providing feedback to the electric vacuum pump control unit. If the power supply to this sensor deviates from specified limits, the control unit registers an abnormality, leading to the storage of this trouble code. The sensor must operate within a specific voltage range to accurately relay pressure information, which is critical for ABS and overall braking effectiveness. The brake booster integrates various components, and the sensor's proper functioning ensures that the braking system performs optimally, without any risk to the vehicle's safety. Several potential causes are associated with the DTC C1244-1C, each requiring comprehensive investigation. First, the brake booster pressure sensor 1 may be receiving voltage outside its operational parameters, indicating a possible malfunction. Secondly, wiring issues such as short circuits or breaks in the wires supplying power to the sensor can cause voltage inconsistencies. This can disrupt signal transmission between the brake pressure sensor and the control unit. Additionally, the electric vacuum pump control unit itself could be faulty, which would prevent it from supplying the necessary power to the sensor. Each of these causes necessitates careful inspection and troubleshooting to identify the exact source of the problem and remedy it adequately. When facing the DTC C1244-1C, certain symptoms may become apparent, indicating critical issues within the brake system. Drivers may notice warning lights illuminating on the dashboard, such as the brake warning light, flagging potential failures in the braking system's electrical components. Moreover, the brake system could become unresponsive, leading to fluctuating brake performance, which is hazardous. If the sensor is not functioning correctly, it may give inaccurate signals, resulting in inconsistent brake pressure application, affecting overall driving safety. Not only do these symptoms pose immediate safety concerns, but they also hint at underlying electrical faults requiring immediate attention. Proper identification of these symptoms aids technicians in diagnosing and resolving the issue more effectively. The first step in troubleshooting DTC C1244-1C begins with the vehicle's operational state. First, ensure that the vehicle is turned to the on mode, allowing the electrical systems to power up and stabilize. After this initial activation, it is crucial to turn the vehicle off and wait for at least 2 seconds. This period allows the onboard computer systems to reset and reevaluate any error states recorded. Following the wait, turn the vehicle back to the on mode to complete this initial step. This methodology helps determine whether the issue is persistent or transient. Properly executing this step lays the groundwork for more detailed inspections of the braking system's components. The second step focuses on inspecting the brake booster pressure sensor 1. Begin by disconnecting the 3P connector from the sensor to prepare it for inspection. Once disconnected, check the output voltage of the sensor while in the IG mode. The voltage should typically fall between 4.5 to 5.5 volts to indicate normal conditions. If the voltage reading is within this range, one can infer that the sensor is functioning correctly, leading to the conclusion that the sensor may have issues rather than the electrical supply itself. Conversely, if the voltage is outside this specified range, further investigation into connected wiring and components is warranted. This systematic approach facilitates isolation of the fault to either the sensor or its related electrical inputs. In the third troubleshooting step, attention shifts towards the wiring and connections relating to the brake pressure sensor. Start by ensuring that the electric vacuum pump control unit's 30P connector is disconnected along with the brake booster pressure sensor's 3P connector. Conduct an inspection of the sensor 1 supply line to determine if it is shorted to power, which could create an incorrect supply voltage situation. Additionally, also check the sensor 1 signal line for any shorts to ground that would adversely impact the sensor's readings. If abnormalities are detected during these inspections, it's indicative of circuit failures that must be addressed. Thoroughly examining these components can lead to the identification of the root cause of the voltage supply issues affecting the sensor. A final troubleshooting step involves inspecting the electric vacuum pump control unit, particularly if previous checks indicated normal conditions for the brake booster pressure sensor and wiring. A visual inspection should be conducted to check for any obvious physical damage, corrosion, or loose connections that might affect the unit's performance. Careful examination ensures that all inputs and outputs are intact and functioning as expected. If no issues are found in the sensor or wiring, then it is likely that the electric vacuum pump control unit itself may be defective. This unit is critical as it provides the vacuum needed for proper brake operation, and if determined faulty, it must be replaced. Accurate diagnosis at this stage is essential to restore proper brake system function operationally. Once all necessary repairs have been made, it is essential to perform a final verification of the repair process concerning DTC C1244-1C. Begin by using the appropriate diagnostic tool to clear the previously stored DTC from the vehicle's computer system. Following this, it is crucial to recheck the operation of the brake booster pressure sensor to ensure it is functioning within the prescribed voltage range of 4.5 to 5.5 volts. Most importantly, take the vehicle for a test drive to confirm that the entire brake system is functioning correctly and the vehicle responds as expected during braking. A comprehensive verification ensures that the initial issues are resolved and provides peace of mind regarding both the driver's and the vehicle's safety. Confirming functionality post-repair is an integral part of any automotive service process. To mitigate the recurrence of issues such as those indicated by DTC C1244-1C, implementing a preventive maintenance routine is advisable. Start with regular checks of critical components like the brake booster pressure sensor to ensure they are operating efficiently. Periodic monitoring of wiring conditions is also crucial, particularly looking for signs of wear or potential short circuits that may arise due to environmental factors or normal wear and tear. Cleaning electrical connections periodically can prevent corrosion and ensure optimal conductivity, which is key for the proper operation of the braking system. By adopting these practices, the longevity of electrical components can be significantly enhanced, leading to greater vehicle reliability, particularly in critical safety systems like braking. In conclusion, understanding DTC C1244-1C is critical for maintaining the safety and functionality of the Honda Civic's braking system. Properly diagnosing and troubleshooting issues related to the brake booster pressure sensor 1 and addressing any electrical faults is essential to restoring system integrity. The methodology outlined in the troubleshooting steps provides a comprehensive framework for technicians to follow, ensuring no detail is overlooked. Additionally, preventive maintenance practices are vital for reducing the likelihood of recurring issues, ensuring long-term reliability of the braking system. By emphasizing both precise diagnosis and proactive maintenance, vehicle performance and passenger safety can be significantly enhanced. Please like and subscribe to the channel. See you next time.